All right, so today we're going to look at graphing exponential functions. Okay, exponential functions, as far as a parent function, which is the kind of simplest exponential equation, takes the form y equals b to the x. So exponentials, the difference is the exponent, or the variable, is the exponent in the problem. Okay? There's two types of exponentials. There's exponential growth, where some quantity gets bigger. Okay? It gets bigger if the b value is greater than 1. And we have exponential decay, where the b value is between 0 and 1. And that's where the graph starts up high and flattens out. Okay? The other piece you're going to notice with exponentials is they always have a horizontal asymptote. Okay? The kind of parent function's asymptote is at 0. There's a definition on your notes if you want to kind of look at it. So we're going to see kind of these graphs that kind of flatten out at a spot and either grow from there or start up high and then come down to an asymptote and approach a value. So when we look at graphing them, one of the things we're going to look at is what does the parent function look like, and then how can I apply the transformations that we worked on in Unit 1 and shift and manipulate the graph. Okay? So you're going to notice a couple of things. I've got a multiplier on the A. That's going to do that vertical stretch. It's going to pull that graph and make it taller. And if it's negative, it's going to flip it over the x-axis, just like we did in Unit 1. We've got this x minus h. Okay? So the x minus h is going to move the graph left and right. Since it's minus, so if we have like x minus 2, it's going to move it right 2. If it was x plus 3, it would move all the points to the left 3. And then lastly, we have that plus k. That's being added on to the y at the end of the graph. So that's going to move the graph up and down. Okay? So now we're going to look at actually graphing some of these different equations and how we do it. All right, so for starters, we're going to look at f of x equals 2 to the x plus 1 minus 3. So the first thing I'm going to look at is, again, what's the parent function? If it was just y equals b to the x. Well, in this case, our base, what we're multiplying by over and over again, is 2. So my parent function is, well, let's use f of x. F of x equals 2 to the x. Okay, so what I'm going to do is I'm going to sketch the graph of that, and then use the transformations, identify what they are from this original equation, and manipulate the graph. So I'm going to start by making a table. Use some points, -2, -1, 0, 1, and 2. What you should have learned from properties of exponents, when you plug in -2 for x, 2 to the -2 is equal to 1 over 2 to the +2, or 1/4. 2 to the -1 is 1 over 2 to the +1, which is a half. Anything to the 0 is 1. 2 to the 1st is 2. 2 to the 2nd is 4. I could put 3 in there. 2 to the 3rd would jump to 8. Notice I'm multiplying by 2. I'm doubling my answers. Doubling a 4th to get a half, doubling a half to get 1, on down the line. All right, so let's sketch the graph of this. All right, so first off, we can start by plotting some points. So -2, so left 2 up about 1/4, left 1 up 1/2, 0, 1, there's my y-intercept, 1, 2, 2, 4, and 3, 8 would be somewhere up there. You can tell that the jumps, the vertical changes, are getting bigger as I double those values. Now sketch the graph. This graph should look familiar to you. It was on some of our transformations and some of the other graphs that we've seen. here's that horizontal asymptote that I'm talking about that this graph flattens out. Okay? So here's the parent function, and now I'm going to look at the transformations and how does that affect the graph. So first off, this plus 1 is attached to the x. Since it's plus 1, it actually moves it to the left 1. So I'm going to go left 1. And then this minus 3 at the end is going to shift the graph down 3. I'm going to go down 3 with it. Okay, so I'm going to do then is I'm going to manipulate every point. I'm going to go left 1 and down 1, 2, 3. Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. I can do this with the half. Left 1, down 1, 2, 3. Okay. The big thing with this is that that horizontal asymptote was at 0. When I shift it down 3, what I'm going to have is a new asymptote.
We have a custodian report to the front office, please. Custodian to the front office. Thank you.
They interrupt me even after school. All right, so I've got this horizontal asymptote at y equals -3. So I know my graph's going to kind of flatten out at that point. There's my new graph that's been shifted left 1 and down 3. Okay? Just to kind of check and kind of verify, I could kind of plug a point in and see what I get. So I'm going to look at this example here, which is x equals -1. I'm going to plug it into my equation. All right, so if I plug -1 in for x, which means I'm finding f of -1, I get 2, so -1 plus 1 minus 3. -1 plus 1 is 0. Anything to the 0 is 1. 1 minus 3 is -2. So I found the point -1, -2. Just to verify, yes, there it is. Left 1, down 2. I've got the point -1, -2. Okay. I could do the same thing. I could have used these transformations with my table versus pulling them from the graph. So to just kind of show how that works. Left 1 would be kind of subtracting 1 from each of the x's. So -2 minus 1 is -3. -1 minus 1, -2. -1, 0, 1, and 2. And then down 3 would be subtracting 3 from the y's. So 1/4 gets a little trickier with fractions. 1/4 minus 3 is -2 3/4. 1/2 minus 3 is -2 1/2, or -2.5. 1 minus 3, -2. 2 minus 3, -1. 4 minus 3, 1. 8 minus 3, 5. Again, remember we saw that -1, -2 point on our graph, and we got it when we plugged it into the equation. So we've kind of confirmed and kind of checked our answer a couple of different ways. Okay, so here's an example of exponential growth with a horizontal and vertical shift. Okay, so now we're going to look at an exponential decay with a couple other transformations in it. All right, for our second example, we're going to look at f of x equals 3 times 1/2 to the x minus 1. Okay, so what's going on here? My base is a half, and as you saw in the beginning of this video, if the base is between 0 and 1, the values are going to decline. They're going to decay. And the reason for that is you're multiplying by half over and over again. So basically you're cutting your numbers in half. Again, I'm going to strip away all of the transformations. So I'm going to get rid of the 3 and the -1 and look at it as just the parent function. F of x equals 1/2 to the x. Make my table again. I'm going to call it x f of x instead of xy this time. I'm going to look at again kind of the same points. Again, from the representation matching activity, you really want to make sure that you find enough points and start to understand the general shape of these guys. That was kind of a struggle for us in there sometimes. So plot enough points, start to learn kind of what the shape looks like as we go through. So when I put in -2, 1/2 to the -2nd. Well, when I have a fraction to a negative exponent, one of the ways I look at it is I first reciprocate the fraction. That's going to kind of take care of the negative piece. So I'm going to flip the 1/2, which is 2/1. And then my exponent turns positive. I remember negative exponents kind of move things from the numerator to the denominator, or denominator to the numerator. Well, 2 to the first, or 2/1 is 2, squared is 4. I put in -1, 1/2 to the negative first, flips the 1/2 to make it 2, and makes it to the positive first. 2 to the first is 2. 1/2 to the 0, anything to the 0 is 1. 1/2 to the first is 1/2. Notice the numbers are getting smaller, they're getting cut in half every time. And then 1/2 to the second is 1/2 times 1/2, which is a 4th. So again, I'm going to take these points and plot them. All right, so when I plot these points, -2, 4, this is going to start up high and then level off. -2, up 1, 2, 3, 4. -1, 2. 0, 1. 1, 1/2. And 2, 1/4. Again, I've got that horizontal asymptote at 0, so I know the graph's going to come through these points and level off. All right, so there's my parent function, and so now I'm going to look at the transformations. So the 3 is a vertical stretch. And the -1 is a vertical shift, down 1. All right, now here's where we have both things affecting the y, both the stretch vertically and the shift vertically. So I've got to follow the order of operations and do the multiplication first. So I'm going to stretch the graph and then move it down in this case. Okay? So we can look at a couple of points and kind of do that. So this y is at a height of 1. When I triple it, it moves up to 3. 1 times 3 is 3. So it's going to be up here at 3. So let's do that first. So here I am up at 3. This point was at a 1/2. When I triple a 1/2, that's a 1/2 plus a 1/2 plus a 1/2. That's 1 1/2. 1 1/2. And 1/4. 1/4 times 3 is 3/4. This point's at a height of 2, so when I triple 2, it's going to go way up to 6. So don't go up 6, go up to a height of 6. So this is 1, 2, 3, 4, 5, 6 over here. So you're going to get this graph. Okay. So that's been the vertical stretch. Now I need to apply the down 1. And you can definitely do this all at one time. I'm going to now shift this graph 1 unit down. Okay. So I'm going to kind of take a look at that. As we take every point, move it 1 down. And get rid of this black graph. And notice what happened. I got a couple points that kind of jumped over the x-axis as I moved them down, and that horizontal asymptote is going to be down at -1. So when I sketch my new graph, a little bit steeper, because of the stretch, and then shift it down 1 so I have a horizontal asymptote at -1 instead of at 1. Again, I could check some points. Let's put in -1 and see what happens. When you put in -1, you have 1/2 to the negative first times 3 minus 1. So 1/2 to the negative first reciprocates the 1/2 to be 2. It makes it 2 to the first, which is 2. Times 3 is 6. Minus 1 is 5. So -1 should be at 5. So if I look at -1, I'm up 1, 2, 3, 4, 5. Got it right. I kind of checked one point. It'd be safe to kind of check a couple other ones, but in general, I feel pretty good about what I did. So the idea here we're looking at is figure out what the parent function looks like, just the b part to the x, eliminate the a, the h, the k, find those points, plot them, then use our transformations that we were working on from Unit 1 and shift the graph left, right, up, down, stretch it, flip it, whatever you need to do. Then you can definitely verify by plugging in a point into the equation and seeing if that point's actually on your graph, which are things you kind of learned from the representation matching piece.